Numbers in scientific notation can only be added or subtracted if they have the same exponents. If needed, an intermediary step is to rewrite one of the numbers so it has the same exponent as the other. Let's take a look at a couple of examples that model this. The simplest example of addition would be 4.0 times 10 to the third plus 5.3 times 10 to the third. Since the exponents are the same, they're both a 3, right? We have 10 to the third, 10 to the third. We're just going to add the coefficients. So here we would want to add 4 plus 5.3 would give us 9.3, and the exponent would stay the same as a 3. This is just saying that 4.0 thousand plus 5.3 thousand equals 9.3 thousand. This problem is slightly more difficult because you need to add one extra step at the end. Here we have 8.0 times 10 to the third plus 5.3 times 10 to the third. We still have the same exponent of 3, so we're still going to add the coefficients. So 8.0 plus 5.3 is 13.3, and we have the same exponent. But this is not in proper form since 13.3 is greater than 10, and in scientific notation we know that first number has to be between 1 and 10. It has to be equal to or greater than 1 but less than 10. And here it's greater than 10, so we need to rewrite this number as 1.33 times 10 to the fourth. We need to change it to our proper notation. This problem here, 8.0 times 10 to the fourth plus 5.3 times 10 to the third, requires an extra step at the beginning because the exponents are now different, right? We have a 4 and we have a 3. So we either have to convert the first number to 80 times 10 to the third or the second one to 0.53 times 10 to the fourth. Either will work, but the latter saves us a step at the end. So we're going to change the second number to have an exponent of 4. So now we can just add the coefficients, 8.0 and 0.53 to 8.53, and they both have that same exponent of 4. So once both numbers had the same exponents, we just add the coefficients like normal. And note that when we made the exponent 1 bigger, that makes the number 10 times bigger. We had to make the coefficient 1/10 as large to keep the number the same. That's my trick, where if the number got smaller, your exponent got bigger, and vice versa. If your number gets bigger, your exponent gets smaller. You have to keep the balance between your coefficient and your exponent.